So let's just see through a few examples, all right? So let's suppose we had y equals x to the power 3, okay? What would the derivative be? Well, following this rule, okay, we should bring the power down, so the 3 climbs down, and we get x to the power of, and reduce the power by 1, x squared, okay? What about y equals x to the power of 7? Okay, same kind of thing. We end up with dy by dx, the derivative. Bring the power down, so we get 7x, then we reduce the power by 1, 7x to the power of 6. Okay. We can even do it with stuff like this, y equals 1 over x. Because we know that 1 over x can be written as x to the power of -1, remember the condition, this thing only works if it's x to the power of something. Okay, so if we have 1 over x, we can rewrite that as x to the power of -1, so x to the power of something, okay? In which case the derivative will be bring the power down, becomes -1, and reduce the power by 1, becomes -2. Which of course, if we wanted to leave it as a fraction, that would be -1 over x squared. Does that make sense? Okay. It would even work with stuff like this. So if I had, for example, y equals 4x to the power of 10, okay, then that means that if I differentiate it, okay, I bring the power down, so I get 4 lots of 10x and reduce the power by 1, 9, which of course I can tidy it up as 40 x to the power of n. So if you like, when you have a constant here, it just comes along for the ride, okay? It doesn't really change anything, you just end up multiplying by the power, okay? What about if I have something like this? So 3x to the power of 7 plus 2x to the power of 5 plus 3, okay? Well, if I differentiate this, okay, I could just treat each term separately, okay? Because effectively, I would be doing this kind of idea, doing all of this kind of idea on each term individually, okay? So let's have a look. So if I just look at the 3x to the power of 7 term, I bring the power down, so I get 3 times 7, which is 21, and reduce the power by 1, x to the power of 6. Okay, then I look at the next term, treat it separately, so the 2x to the power of 5 term, right? I bring the power down, becomes 2 times 5, which is 10, and I reduce the power by 1, which is x to the power of 4, okay? Now have a think. On this last term here, I would end up with just 3. Now, there's a couple of ways that you can think about it, okay? Firstly, you can treat this as 3, then what would the power of x be? Well, it would be x to the power of 0, because of course x to the power of 0 is just 1, okay? Which means that if I follow the rule, I bring the power down, so it becomes 3 times 0. Well, and I know that I don't have to do any more, because 3 times 0, okay, 0 times anything just ends up being 0. So effectively, there'd just be nothing there. Now that's interesting, okay? So I end up with a constant term, and I know that when differentiate a constant term, just like a number, it ends up being 0. That shouldn't be a surprise, because if you think about the graph of y equals 3, it would look like this, okay? So this is the graph y equals 3. It would literally just be a flat horizontal line that passes through the y-axis at 3, okay? Now, if you think about it, what would my change in y over change in my x be? What would my derivative be? What's my rate of change, okay? Well, if you look, there's no change in the y direction. There's no change whichever happens in the y direction. I just simply go across. I never go up or down, okay? So in which case, my change in y will be equal to 0. Therefore, my gradient has to be 0 because I'm never changing in the y direction. Does that make sense? Okay, so just because we're slightly short on time...
We use it up in programming stuff.
Is that Notepad++? Notepad++?
Yes.
Yeah. Just because we're slightly short on time, I'll just quickly go through this one. Okay. So first things first, I'm going to rewrite this so that I'm in a position that I can differentiate it. So I get 3x cubed plus 4x plus x to the -1. Okay, so I could equally write y like that. Okay, so let's first of all go for my point. So to find my point, I know one of my coordinates is 1. To find my corresponding y, I need to stick it into this equation. Yeah? So I get 3 times 1 cubed plus 4 times 1 plus 1 over 1, which is 8. Yeah? Okay. Then I need to go for my gradient. So to find my gradient, I will need to differentiate this. So if I differentiate this, what do I get? Yep. Yep. Bring the power down, minus x to the power of -2, which if I wanted to, I could rewrite as 9x squared plus 4 minus 1 over x squared. Okay. Now remember, this is my gradient function. To find the value of my gradient, I need to stick in the point which I'm after, x equals 1. Okay, so therefore my gradient is going to be 9 times 1 squared plus 4 minus 1 over 1 squared. So I'm going to get 9 plus 4, which is 13, take away 1, 12. You all happy with that? I'm simply just sticking x equals 1 into this formula.
Oh, okay.
Yeah, to find my value of the gradient. So I now know that my gradient is 12. Okay? And then I can just go ahead and do y equals mx plus c. That's the easiest bit. Okay? So if I say y equals mx plus c, stick the relevant thing in the relevant place. So my y is 8, my m is 12, my x is 1, and I don't know what my c is. Well, would you be happy that if I solve this equation, I get c equals negative 4? So therefore, the equation of my tangent to this curve at x equals 1 is going to be y equals 12x minus 4. Is that okay? Okay, now that's tangents, okay? There's another type of question which is very similar to this, which is not to do with tangents, but it's to do with, normals. Okay, so what on earth is a normal? Okay, so this is a tangent. Okay, we're happy tangents are like our zombies on our roller coaster. Okay, so a tangent is like a zombie on a roller coaster, arms outstretched in front of them, and it's the direction which their arms are facing in as they move along this roller coaster. Okay? Well, if you think about it, when normal people get on roller coasters, which direction are their arms going? Like that. Yeah? Like you've got your arms in the air when you're doing roller coasters, right? So therefore, if I was a normal person riding along this roller coaster, zombies would be the tangents. They've got their arms outstretched in front of them. Whereas the normal people go along the roller coaster, arms outstretched above them. When they get to this point, which direction are their arms facing? Like that. Okay? So in fact, we call this line a normal, because it's what normal people do when they go on roller coasters. You're all happy with the distinction between a tangent and normal?
What about Pythagorean people?
Sorry?
What about Pythagorean people?
I don't. Tangents, zombies. In fact, let me write that in. Tangents are zombies. Okay. Normal are what normal people do. Okay.
That each angles when normal cross the 90 degrees.
Perfect.
Okay.
So those two lines, normal lines and tangent lines, are 90 degrees to each other. They're perpendicular. Yeah. Good. Okay. So how would I answer this question now then? Find the equation of the normal to y equals x squared at x equals 4. How would I answer that equation? How would I answer that question? Well, I do exactly the same thing as before.
Yeah.
I try and find a point and I try and find a gradient. Okay, has the point changed? Still exactly the same point. So how do I find the point? Given my x coordinate is 4.
Like point is 16.
Exactly. So if x equals 4, then that must mean that y must be equal to 4 squared, which is equal to 16. So my point is 4, 16. Okay. Now this is where I need to be careful. Because is the gradient the same? No. Like, look, that's very positive. That's negative. Does anybody know the relationship between gradients of perpendicular lines? Lines which are at 90 degrees to each other? Does anybody know? Good, it's something to do with -1. The idea is, if you multiply gradients of perpendicular lines together, so let's suppose these are gradients of perpendicular lines. So M1 might be my tangent line, M2 might be the gradient of my normal line. If I multiply them together, I should get -1. Should get -1. Or if I rearrange this equation, I can say that one gradient is just the negative reciprocal of the other gradient. Can you see how I got that? I just simply divided through by m2. Okay. So, in other words, if I can find the gradient of my tangent, which we can, I should be able to find the gradient of my normal just by using this relationship up here. Okay, so let me show you. How do we find the gradient of our tangent? I need to differentiate. So, okay, let's differentiate this. What do we get? 2x, perfect. Okay. Now, I want the gradient of my tangent at x equals 4. So how can I do that?
I didn't get like why m1. Like where did they get that? I didn't.
I will come to that in just a second.
Okay.
Okay. So let's keep going with this. Here is the relationship which links together the gradients of all my tangents along y equals x squared. I want the value of the gradient when x equals 4. So what is the value of my gradient when x equals 4 at my tangent? 8. That's my tangent. Okay, that's my tangent. But if I know the gradient of my tangent, I know the relationship is going to be the negative reciprocal, which means that the gradient of my normal, the one which I'm after, is going to be what? Negative 1 over 8. Does that make sense to everyone? Okay, so that's my normal. Okay, so that's my gradient which I'm after. And then the rest is just exactly the same. Just exactly the same. Okay. Now I'm going to be a little bit lazy here. This relationship up here, so I'll finish it off in just a second. This relationship, the gradients of perpendicular lines, there is a really easy proof for it. I have got it online as a video, okay? So just search for the relationship between the gradients of perpendicular lines, and then that will come up for you. So if you're interested, go away and look it up, okay? But if you're not interested, just accept it.
Okay.
Okay, good. And then I'll just finish it off. So, okay, just very quickly, y equals mx plus c. Let's stick in my gradient and my y and x value. So my y is 16, my gradient is negative 1/8, times by my x value, which is 4 plus c. Let's do a bit of tidying up. So I get 16 equals negative 1/2 plus c. Multiply both sides by 2, so I get 32 equals negative 1 plus 2c. If I fiddle around with that, I get 2c equals 33, which means that c must be equal to 33 over 2, which means that the value of my equation of the normal to this curve at x equals 4 is going to be negative 1/8 times x plus 33 over 2. Okay? If you want more examples, by all means, have a look in here. Have a look in the lecture notes.
I mean, what I don't understand is like we use for like before this you have like x over 3 and we use like one just one gradient, but for this like we use like m1 product with m2.
Before it was a different question. Before it was asking for the equation of the tangent line.
This
Okay.
is normal line.
This is for the equation of the normal line.
Oh, okay.
Okay, so it's what I'm trying to show you, the two questions are near enough identical in terms of how you answer them. The only slight twist is in this line here. Okay? Once you find, remember, differentiation gives you the gradient of the tangent. But you know, if you want to find the gradient of the normal, the relationship between gradients of perpendicular lines. They're just negative reciprocals. So once you find the gradient of the tangent, you just negative it and flip it upside down. And then you find the gradient of the normal. Then everything else is the same. Is that clear?